All right, so we're going to do 14 together. For this one, you can think of this as just a 1. So when you distribute a 1 through, it doesn't change anything. You just have the t plus the 3. Here you're distributing a 2. 2 times the t and 2 times the 5. All right, and that equals 34. And now we need to simplify the equation. We have 1 and 2, that gives us 3 t's. We have a 3 and a 10, that gives us 13. Then I'm going to subtract that 13 over. I have 3t equals 21, and then I'm going to divide by the 3, which is going to give me the t equals 7. For number 28, it says Stan wants to make a rectangular garden. He has 34 feet of fencing to put around the perimeter of the garden. So if the length is 5 more than the width, find the dimensions of the planned garden. When they ask for dimensions, that means they want the length and the width. They want all the dimensions, okay? So the first thing you need to know is that it is a rectangular garden. Sometimes part of your plan is to draw a picture. So if it's rectangular, you can certainly draw a rectangle, all right? When you draw the rectangle, you want to label it. You have length and width, all right? And then they specifically gave us a relationship. They said the length is 5 more than the width. So we could actually write the length as the width plus 5. 5 more than the width, all right? Another key word they gave us here is the word perimeter. All right, that should lead us back to one of our equations that we had. One of our equations was for perimeter of a rectangle. All right, so when we're finding perimeter, we're just finding the distance around. And the distance around is going to be twice the width plus twice the length. All right, so you need to remember perimeter formula. And so my perimeter is going to equal 2 times the width plus 2 times the length. All right. But we don't want to write the length like that. That doesn't help us. We have 2 different variables. We want to write it like this. So I'm going to say 2 times the width plus 2. And instead of length, I'm going to write this length. W plus 5. And that equals how much fencing he has. How much fencing does he have? 34. And now I have a problem I can solve. What's my first step to solve here? I need to distribute, right? So 2w plus 2w plus 10 equals 34. Combine my like terms. 4w plus 10 equals 34. All right. I'm going to subtract that 10 over. 4w equals 24. And then my last step to solve this piece is to divide. W equals 6. What have I solved for? The width. So my width is 6 feet, but I am not done. They want both dimensions, which means to find the length, I have to add 5 to it. And now I'm finished. All right, so the first question they ask is, how is this different from the ones in the prior section? What's the difference between these and what we've been solving? So you'll notice that we have variables on both sides of the equal sign, all right, which we have not been doing. So when you have variables on both sides of the equal sign, you do need to simplify both sides as much as you can. And then you need to move all your variables to one side of the equation and all your numbers to the other side of the equation, all right? So you will be moving variables as well. When you move a variable across the equal sign, you're going to add or subtract to get it over there, just like you would move a number across the equal sign, okay? So let's look at this first example. They want us to solve 2x plus 5 equals x minus 2, all right? Now, in this case, both sides are as simple as you can get them, all right? If you look at this, I cannot combine the 2x and the 5. Those are not like terms. This has an x, this doesn't. I cannot combine the x minus 2. This is an x, this doesn't have an x. So really the sides themselves are as simple as they get. What I do need to do is make sure that my variables go to one side and my numbers go to the other. And it actually doesn't matter which side. But I'm going to move my x over. In order to move it over, I have to add or subtract. I want to zero it out, so I want to do the opposite of what's going on here. This is a positive x. To make it 0, I have to subtract x. Everybody see that? X minus x, it's going to 0 out. If I subtract x on this side of the equation, I must do it on the other. And you want to line it up with the like term, all right? So now I have 2x minus 1x. How many x's do I have? 1x, right? Now, since I moved my x's to this side, I want to move all my numbers to the other. So I want to cancel out this 5. How do I cancel out a positive 5? What do I do with it? So I'm going to subtract 5 here. 5 minus 5 equals 0. And I'm going to subtract here. All right? Now, one thing that people often forget is to bring down this equal sign. All right? So make sure that you bring that down and make sure that you do your subtraction correctly. We have a negative 2 minus 5. Remember, it's the same thing as adding the opposite. Negative 2 plus a negative 5. What do I have there? I have a negative 7. So x equals negative 7. All right, and this would be my answer. You can check them. All right, so if you want to go back and say, did I do it right? Go back to your original and plug it all in to check it. So if you have to make sure you plug it into every x. I have 2x, so 2 times negative 7 plus 5 equals, I have another x, so negative 7 minus 2, all right? Do order of operations on each side. 2 times negative 7, then 14 plus 5. On the other side, I'm going to do negative 7 plus a negative 9. All right. What? Don't do that. Oh, this should be a 2 here. There we go. Plus a negative 2. Sorry, I already solved it for you. Negative 7 plus a negative 2 is negative 9. They equal. All right. They equal. So you want to check it and make sure that you did it. Once you check it, you're literally just doing order of operations on both sides. And don't solve it before you write it down. That works too. Example 2. All right, for example 2, you have 2 sides that are not simple. These are not as simple as you can get them. So you have to simplify your sides first. For these, you're going to have to actually distribute 3 times x, then 3 times negative 4. On the right side, you're going to have to distribute that 4. 4 times x, 4 times negative 6. All right? And once again, variables to one side, numbers to the other. Now, here's the thing. I always move my variables so that I don't have a negative if possible, all right? Some people like to always move their variables over to the left-hand side. That's just what they want to do. It doesn't matter which way you do it, you will get the same answer, all right? So let's say you're the type that always wants to move your variables to the left side. Then you're going to subtract the 4x from both sides. And it will cancel here, and you have 3 minus 4, which is negative 1. Well, that means you're going to have to move your numbers always to the right. Negative 12, positive 12 zeros. So I'm going to do this. Make sure you bring down your equal. Negative 24 and positive 12 is negative 12. If you do that, you are not done. You have to have x all by itself. What do you have in front of your x? A negative 1. So here you're going to have to divide by negative 1 to get your answer x equals 12. All right? Now, if you want to always move it where it seems the simplest, like let's say you want to do it to the other side. Let's say I'm like, well, if I subtract it over, I'm going to get positive. So let's move my 3x then to the other side. If I move my 3x over, I'll still get 1x here. But then I have to move my 24 over to the other side. Bring down my equals, and I get positive 12. Those are the same things. I just moved my variables to the left on the first way. I moved them to the right on the second way. Either way, you will get the right answer. Variables just have to all go to one side. Numbers have to all go to the other, and then you're going to divide. All right, but it doesn't matter which side you do it on. If you look at the top of page 81, simplifying your equations. Simplify both sides by removing parentheses. That means distributing and combining like terms. Move the variables to one side of the equation. Move the constants to the other side of the equation. and then multiply or divide. All right, so you're constantly looking for, is it simplified? Then start moving variables and numbers. So is this simplified? Is that as simple as you can get it? Why? We have like terms. How many x's do we have? 5 and 3. We have 8 x's minus 4 equals x plus 2. We have simplified those as much as we can. All right. Now I'm going to move my variables. I'm going to choose to move these over to the left. So that means I subtract that x here. I have to subtract it here. It has to cancel out. Whatever you do to it, it has to cancel. 8 minus 1 gave me 7. If I moved my variables to the left, that means I have to move my 4 over to the right. You always do the opposite when you're going across the equal sign. It's going to zero out there, and I get 2 plus 4 is 6. That equal sign has to come down. All right? And then I have one more step. My last step here is going to be to divide. X equals 6 over 7. You cannot reduce that, so you are done. All right? You cannot reduce it, so you're done. If you could reduce it, you would reduce it. Any fraction. For this one, it's very similar. They're just getting a little more complicated. So 4, 5, and then 6 just gets a little more complicated, and you can have special cases. All right, so example 4 is one of your special cases. We would solve this exactly the same way. All right, we're going to start by distribution. We're going to say 3 times 4x and 3 times negative 5. And don't forget that plus 2. That tends to be forgotten sometimes. On the other side, we're going to distribute the 2. 2 times 6x plus 2 times 3. On the left-hand side, I have like terms. So I have 12x minus 13 equals 12x plus 6. I need all of my variables on one side. Negative 12x subtracts and zeroes out. Negative 12x. I have 0 x's over here. All right. When I do that, I get this. What's left over here is negative 13 equals, and what's left over here is 6. When does negative 13 equal 6? Never. Negative 13 never equals 6. When you cancel out all of your variables and you get a statement that is not true, your answer is going to be no solution. No solution. You can write no solution, or you can write the symbol for no solution. But if you cancel out all of your variables and you get a false statement, it is going to be no solution. That is one of your special cases, no solution. All right? Look at number 5. All right? So once again, we need to simplify both sides first. Don't forget that this is a 1 here. I'm going to leave the 8 alone, and I'm going to distribute the -1 first. -1 times x is -x. -1 times -4 is +4. On the right-hand side, I'm going to distribute the -2. -2 times x, -2 times -6. And don't forget your plus x there. All right? I need to simplify both sides. I have 8 and 4. So I have 12 minus x. On the other side, I have a 12 and then -2x and +1x. All right? If I move my variables over to one side, add x there, it cancels. Add x here, it cancels. Both of my variables canceled. I'm left with 12 equals 12. When does 12 equal 12? This is exactly opposite of the other one. This one is a true statement. When you cancel all your variables, you're going to have a special case. One of two things can happen. True statement or false statement. If it is a false statement, no solution. But if it's true, it is all real numbers. And you can actually just do your little R like that, or you can say the words all real numbers. But every single number that you pick will work for that problem. No matter what x you put in there, it will work. On the other one, you could put whatever number you want to, it will not work. All right? And so those are your two special cases. You can get a true statement or a false statement when you cancel out all of your variables, but your special cases will always cancel out your variables completely. All right, so let's look at this one. This one's way more complicated than the one we just did, but it's going to end up the same. We have 2 times x, 2 times -3. And don't forget this +6 out here. Then we have 3x plus 2, and this is a -1 we are distributing. -1 times 2, -1 times -x. All right? On this left side, when we combine a -6 and a +6, it is 0. So we have 2x plus 0, which is just 2x. On the right-hand side, when we combine the 2 and the -2, that also zeroes out, and we have 3x plus 1x. We have 4x plus 0, which is just 4x. All right? When you have something like this, it is not a special case. All right? You still have x's left, which means it's not a special case. So when you have this, you're going to see it will always work out with 2x or whatever it is equals 0. And when you divide 0 by anything, you get 0. So when you end up with something that looks like this, and something times x equals something times x, your answer is always going to be 0. Because one side's going to zero out, and you're going to say 0 divided by some number. All right? The only time you have a special case is when your x's go away completely. All right? When your x's go away completely.